Hello everyone, welcome back to the binary tree series. Today we will be solving a very popular binary tree problem, which is finding the maximum depth of a binary tree. So the problem says given the root of a binary tree, return its maximum depth or height. A binary tree's maximum depth is the number of nodes along the longest path from root node down to its farthest leaf. Now let us take an example to understand the problem. And so this is a binary tree. We have to find the maximum depth or height of the binary tree. So the maximum height is the longest path taken from root to the farthest leaf node of this tree. So how many nodes are in between root and the farthest leaf node? We have 1, 2, 3, 4, 5, right? So the depth of this tree is 5. Now how can we solve it is at each node we'll check the maximum path along its left subtree and along its right subtree. So whichever is greater, we'll take that. So suppose we are at 3, okay? So we'll take 1 plus, the answer should be 1 plus maximum of left comma right. This left is nothing but the total number of nodes along its left that forms the maximum depth of this subtree, okay? And the right is nothing but the total number of nodes along its right that forms the maximum depth of this right subtree, right? This right subtree. So for this, we will recursively go to the left child of 3 and right child of 3, right? So suppose now we are at, for 9, the result will be 1 plus maximum of left and right. So from left it will get a 0. Similarly from right it will get a 0 because it has no left or right nodes. So 0 comma 0, and this 1 is basically to count this current node, okay? So the answer will be 1. So from 9 it will return 1 to its parent. It will return 1 to its parent, right? Now we'll go to the right subtree of 3. We'll go to the right subtree of 3. So we have 20. Max depth at 20, we need to do 1 plus max of left comma right. So to know the values of left comma right, we'll again recursively go inside 15, and from 15 we'll go inside both the left and the right child, both the left and the right child. Similarly from 20 we'll go to the, okay, so now at 6, now we are at 6. So what should 6 return? So 6 does not have any left child or right child, right? It does not have any left child or right child. So as per this equation, 1 plus max of 0 comma 0, 6 should return 1 to its caller, okay? Now we are at 8, okay? So 8 is not the leaf node, so we'll again traverse to the left child. So from 14 we will get 1 back. We'll get 1 back because under 8 it is 14 is the only node. 14 is the only node which is under the left subtree of 8. So it returns 1. Okay, so the right subtree of 8 will not return anything, it will return 0. So what will 8 return to its parent? No, now at 8 we have 1 plus max of left, we have 1. It got 1 from its left child and 0 from its right child. So the answer would be 1 plus 1. 1 plus 1, which is 2. So 8 will return 2 to 15. 8 will return 2 to its parent 15. So you see under 15 in the right hand side, like under 15 on the right subtree, how many nodes are there? 2. So 8 returns 2. Okay, now 15, if you look at node 15, from left it has got 1, from right it has got 2. So what will 15 return? 15 will calculate 1 plus max of 1 comma 2, which is 1 plus 2, 3. So 15 will return 3 to 20. 15 will return 3 to 20. If we see on the left hand side of 20, the maximum path is 15, 8 and 14. This is the maximum path. Okay, so 15 returns 3. Now what will 20 get from its right child? 20 will get 1 from its right child because 7 is the only node. Okay, so 20 will get 1 from its right child. So now 20 has 3 from its left child and 1 from its right child. So what is 20 going to return to 3? 20 will return 1 plus max of 3 comma 1, which is equals to 1 plus 3, 4. So 20 will return 4. 20 will return 4 to 3 to its parent, right? So now we are at the root node. So we will calculate the value from the root node, which is 3 got 1 from its left child, and it got 4 from its right child. It got 4 from its right child. So max of 1 comma 4 is 4. So 1 plus 4 is 5. So this is our depth. This is our maximum height from leaf, from root to leaf. This is now the time complexity for this approach will be big O of n, because each node in the binary tree is visited exactly once. Okay. So for every node, we compute the depth of its left and right children, which are independent calls. So if there are n nodes, the total work is O of n. The total work is O of n. Now, the space complexity for this is, since we are using recursion, we have to store the function calls in stack, right? The height of the call stack depends on the height of the tree. Let's say h. Okay, so in worst case, in case of skewed trees like a linked list, the recursion depth is O of n. Okay, the recursion depth is O of n, right? In the best case, in case of a balanced tree, the recursive depth should be O of log n. Okay, O of log n. Now let's quickly see the solution. It's a pretty straightforward solution. In case the root is null, which is the base condition, we are returning 0. Okay, we are recursively going to the left subtree, root dot left, right equals to max depth root dot right, and then as per our calculation formula, we are doing 1 plus math dot max of left comma right, right? So this should return the maximum depth or height of a binary tree. Let me run this problem and see. Yep, our test case is passed. Let us submit it and check. Yep, beats 100%. Yep, it passed. Thank you so much for watching this video. Please like, share, and subscribe.